This lecture about compiler design. Myself Konkon Jana, Assistant Professor, Greater Kolkata College of Engineering and Management, JAS Group. It's a joint venture. In this section, we will start lexical analysis. In lexical analysis, we will learn the role of the lexical analyzer, tokens, patterns, Lexemes, input buffering, specification of a token, recognition of tokens, finite automata, form a regular expression to an NFA conversion, from a regular expression to DFA conversion, design of lexical analyzer generator, that is LX. First, I give introduction about lexical analysis. What does mean by lexical analysis? The first phase of a compiler is called lexical analysis. What I have told you, first page of a compiler is called lexical analysis or scanning. Compiler means the stages of compilation, first stages of compilation. The lexical analyzer reads the stream of characters, making up the source program and groups the characters into meaningful sequences. For example, if I say this is the source code, now all this source code will be grouped to convert it to some meaningful characters grouped together with some symbol and another type of identity. Okay, this is called Lexemes. Okay, so what is the use of Lexemes? What I have told you, Lexemes code and characters meaningful sequence. Lexemes is the meaningful sequence of code and characters. Meaningful of what sense? Meaningful to the next stage. What I have told you? Meaningful to the next stage. Clear? So, for each lexeme, the lexical analyzer produces as output a token of the form. Okay, the form of the token, it will be generated. So in which form it will produce? It will produce in the form of a token, where token name will be present as an attribute, and another attribute is the value. Okay, so token name is about the symbol. It is about the symbol, meaningful symbol for the next stage. Okay, basically this is the abstract symbol. Okay, this is the abstract symbol. And what about the attribute value? That will point to symbol table. Okay, that will point to a symbol table. Attribute value that will point to symbol table. Okay, what I am writing in whiteboard, that you can note down for your reference. Specifically, these terms are useful for your reference. Okay, so that each passes on the subsequent phase, that is in which phase that will be passes to the subsequent phase, that is the syntax analysis. Syntax analysis, this is the lexical analysis. This all term first phases, analyzing and to make the Lexemes belongs to lexical analysis. After that, syntax analysis will be started. And this Lexemes will be passed to the next, on to the next phase, that is the syntax analysis. So in the token, the first component token name is an abstract symbol. Abstract symbol. Okay, that is used during syntax analysis, and the second component is attribute value, and it points to an entry in the symbol table for this token. Okay, and information from the symbol table entry is needed for what I have told you, for semantic analysis, and the code will be generated in that way. Okay, so this is the very basic of lexical analysis I have told you. This is the theoretical mechanism how it will work there. Okay, now I will give an example. For example, suppose a source program contains the assignment statement. Suppose a source program contains the assignment statement. Okay, which assignment statement it will contain? Which assignment statement it will contain? Suppose the assignment statement is suppose this is the position, this is the initial value, and rate into 60. So this is an assignment statement. Initial plus rate multiplied by 60 is assigned to position parameters. Okay. Now the characters in this assignment could be grouped into the Lexemes and mapped into the tokens passed on to the syntax analysis. So before going to the syntax analysis, what will be happen? I will discuss it one by one. First, that is the number one. What will be happened? Position is a lexeme that would be mapped into a token. It's have a ID and a its have a ID and the lexeme will be position. I have expressed this one. Position equal to initial plus rate multiplied by 60. Okay. Now, so in first step, what will be happen? Position will be the lexeme. Position is the lexeme. Okay. And the token is with ID and a value for the single table. This is the token. Okay. This is the token. So where ID is an abstract symbol standing for identifier and one points to the symbol table entry for position. So what I have told about ID? ID is the abstract symbol. Okay. And what about one? This is the that will point the position into the symbol table. Point position onto the symbol table. Okay. So the symbol table entry for an identifier holds information about the identifier such as its name and type. Its name and type. Now the stage 2. Next stage. What will be happened? Already I have discussed about the position parameter. Now next is the assignment symbol, that is equals to. The assignment symbol equals to is a lexeme here also. That is mapped into the token equals to. Any symbol, note that any symbol equals to plus star will be mapped to the token itself. Specifically, there should not be any reference table. So what I have told you here, next we will go for the assignment symbol as a lexeme, and that will be that will be mapped into the token equals to. Okay, so here equals to the assignment symbol is the lexeme. That is the assignment symbol is the lexeme. Okay, and where it will be mapped? What is the token? For position, I have mentioned the token ID, comma 1. Okay, this is a type of token for the position. Now, what is the token for equals to symbol? Assignment symbol. Okay, this is mapped into this token. Okay, and the token is this. So here others token and which is required to map the symbol table is not required. Okay, since this token needs no attribute value, we have omitted the second component. We could have used an abstract symbol such as assign for the token name, but for notational convenience we have chosen to use the lexeme itself as a name of the abstract symbol. Nothing is required. Right? Okay, so the symbol already we have identified and compiled here, that is equals to. Next stage number 3, initial is a lexeme that is mapped into the token id comma 2. Suppose where 2 points to the symbol table entry for initial parameters. For initial parameters, what I have told you here, the lexeme will be initial. Okay, and the token will be id with the address reference 2, that is the token. Okay, and here 2 points to the initial symbol table. Here 2 points to initial symbol table. Initial symbol table. Okay, so next parameter already have compiled and the token is ready for syntax analysis. Now stage 4, that is number 4. What we have to tokenize right now? The symbol plus. So here plus is a lexeme that is mapped into the token plus. Okay, so plus is a lexeme that is mapped into the token, and the token I can use into the token plus. Okay, Clear? So here class is the Lexeme and token is class itself. Already I have told you. Now go for the next, that is number 5. The parameter is rate. So here rate is a Lexeme that is mapped into the token ID 3, where 3 points to the symbol table entry for rate parameters. Okay, so what I have told you, rate is the Lexeme, okay, and ID3 is the token, and 3 is the rate which map to the symbol table. Okay, so we have reached to this point right now, and the next state, that is number 6. Okay, that is the multiplication operator. As for example, if I told you the multiplication operator, star is a Lexeme here that is mapped into the token star. So here star is the Lexeme, okay, and the token is also star. Clear? Token is also star. So we have reached to the point star, that I can say the multiplication operator. Now the next stage, that is number 7, which is actually right now pending the 60. So here 60 is a Lexeme that is mapped into the token 60. I have told about the symbols, arithmetical symbol operators, any type of operators, okay, that are treated as the Lexeme itself, and its abbot token that will be symbolized to the symbol directly. In similarly, the constant value here 60 also is a Lexeme, and it is true for all the constant value. Okay, 60 is a Lexeme that is mapped into the token 60 itself. So here we write 60 is the Lexeme, okay, and the token is also the symbol list. Clear? Symbol also list. So we have reached to this point. Now blanks separating the Lexemes would be discarded by the lexical analyzer. That means the bracket that are separating the Lexemes would be the discarded by the lexical analyzer. If there is anything or any type of spaces, white spaces, blanks that have no meaning with respect to the compiler, that will be discarded by the lexical analyzer. to make the token. So after the lexical analysis, the expression position equals to initial plus rate multiplied by 60 will be represented using corresponding tokens. Alright, we have converted on the tokens. So the expression after analyzing will be ID, that was for the position, and it have the symbol table position this. Next the symbol equals to, and the token is this. Next token for initial, this is the next token, this is plus itself the rate. Okay, this is the token. Again we have get the another symbol, that is star, that is multiplication, and another token we have itself is 60. Okay, so in this representation the token names equals to, plus, and star are abstract symbols for the assignment, addition and multiplication operator respectively. So what we get after lexical analysis? Just watch it, what we have get. Okay, in our code we have written this one. Okay, and lexical analyzer make it to the tokens that will be ready for the syntax analysis. So we have discussed about the lexical analysis, and we will discuss it later in the subsequent lecture in details. Thanks for watching.